Hello everyone. Today we're going to review a number of CPUs for our SuperSocket 7 CPU test. I'm using a Soltec motherboard using a VIA MVP3 chipset with 128 meg of RAM, a Voodoo 3 2000 PCI, Windows 98, a 30GB IDE hard drive, a PCI Ethernet card, and no sound. So this motherboard is a late model SuperSocket 7 board, one of the last AT based boards. As you can see, it has both ATX and AT power supply. In this case, I was using the ATX power. So this motherboard has 512K of cache. While not the fastest SuperSocket 7 motherboard, it has proven to be a big step up from the previous motherboard, especially with AMD CPUs. I may do another video later comparing the benchmark results of this motherboard versus the SAS board, but today we're just going to focus on the CPU benchmarks. So first, I'll discuss some CPUs that were unable to be included in this set of results. The first is the Win chip. Unfortunately, this CPU did not boot on this motherboard. Either the chip is dead or there are some compatibility issues. So unfortunately this chip was not able to be tested. The next chip is this AMD K5. I actually have another one that I am including. It is also a 100 MHz K5, but you can see that it is rated for PR133, whereas the PR100 didn't boot in this motherboard. Now I believe the reason for that is the PR100 needs a 1.5x multiplier and the motherboard does not go down that low. The same is true for this K5, but you are able to set the motherboard to a 2x multiplier, and then internally this CPU will run at 1.5x. So they're both 100 MHz. It would have been lovely to compare them, but in this case, this PR100 100 MHz K5 unfortunately was not included. The next CPU not included is this PR333 from Cyrix. Now this one, while worked, had a lot of stability issues. I'm not sure if it's a compatibility issue or maybe the voltage on the motherboard needs to be cranked up a bit higher than the 2.9 that I had it set at. But this seemed to have all sorts of memory issues while using it in this motherboard. I'm not sure why. Every other CPU was fine, so there is some odd incompatibility here, so this unfortunately was not included. And the final chip that I haven't included is this PR333, primarily because it benchmarks slightly slower than the other PR333 that I have included. This one here runs at a 75 MHz frontside bus with a slightly faster clock speed because of it, whereas this one has a slightly slower clock speed due to the faster frontside bus and lower multiplier. So I've decided not to include that one simply because it ran a bit slower. I did do some initial benchmarks with it, but it was just not as quick. So let's go over the CPUs that are included. The first one here from Intel is a Pentium 133. This is your bog standard Pentium 133. No MMX technology. So this is the slowest Intel CPU that I have for this benchmark. The next one from Intel is the Pentium 233 MMX. This is the last Socket 7 CPU that Intel produced, and this runs at 233 MHz. It has more cache and has MMX technology. So this is quite a lot faster than the 133. Now you can overclock these. I have not done any overclocking in this set of benchmarks, and I may do that later. The next CPU, as previously shown, is the AMD K5, running at 100 MHz. So this is the slowest CPU in terms of megahertz tested today. The next one is the AMD K6 at 200 MHz. This one has MMX technology, but it does not have 3D Now technology, as it is the original K6. Then we have the K6-2, the first one being a 300 MHz K6-2. So this one, I tested it at the 100 MHz frontside bus at 300 MHz. The next one is another K6-2, but this time at 500 MHz. So I was curious to see how much of an improvement there was when going from 300 MHz to 500 MHz. So this is again a 100 MHz frontside bus running at a 5x multiplier. The last AMD chip is this K6-3 Plus. This is the low voltage 1.6 volt version. For this test, I ran it at 500 MHz, so we can compare it directly to the 500 MHz K6-2. And the motherboard could only go down to 2.1 volts, so I ran it at 2.1 volts. It did not run warm at all during the test and was stable. Now, I did try and run this at 600 MHz as well. Unfortunately, that was unstable. Maybe if you cranked it to 2.2 volts, it would work. I wasn't game to do that, and 500 MHz was fine. Now, the other chips are the Cyrix. This is the 686 PR200. This runs at 150 MHz on a 75 MHz frontside bus. This one had some issues in the last set of benchmarks. Not that there's not any problems with the chip. It's just a bit of a finicky chip and does not support all the Pentium instructions. So I was interested to see if there were any differences when using this newer motherboard. And finally, the Cyrix M2 PR333. So this one's running on a 75 MHz frontside bus with a 3.5x multiplier. So this is so far the fastest Cyrix chip that I have tested. And that is the list of CPUs that we will be reviewing today. So let's jump straight into the benchmarks. The first set of benchmarks we're going to look at today is CPU Z. As I've stated before, this I feel is a very good benchmark to look at optimal CPU performance. It seems to not be impacted hugely by the memory throughput, frontside bus, and other parts of the system. So this seems to give me a pretty consistent set of results across multiple motherboards for the same CPUs. I also checked with the developer, as I previously stated in another video, and the floating point tests don't use any MMX or 3D Now instructions. So it means that we can compare these fairly well. So first, let's take a look at the integer performance of each CPU. So the first chip here is the AMD K5 running at 100 MHz. So you can see here, this actually for the megahertz matches up with the Pentium 133 pretty well. It is only a couple of points off the Pentium 133. And while obviously by far the slowest CPU here, it's sort of performing within expectations. And for example, if it ran at 133 megahertz, it would probably be quite a fair bit faster than a Pentium 133. Now, the Cyrix PR200 here did very well. It is running at 150 megahertz, so it is, a reasonable step up from the K5, but still does very well. The K5, if running at 150 megahertz though, would probably outperform this CPU. So clock for clock, the K5 out of the three seems to be the best for integer performance in this benchmark. The next CPU we look at is the PR333. Now this is obviously running at a lot higher frontside bus. So it's running at 262 megahertz. So that's quite a lot higher. And you can see that really for the clock speed, it is not significantly higher than the AMD K6. So while still decent, not as a big jump as you would like to see for something running at that megahertz. The K6 did very well here, outperforming the integer performance of the Pentium 233. And just remember that the K6 here is running at a slightly slower megahertz as well, so doing quite well. The next CPU is the K6-2 Now this gets quite a big jump. Now it is running on the 100 megahertz frontside bus, so that definitely has quite a big improvement, as you can see in my previous video when running at 66 megahertz. But that's quite a nice jump. The jump to 500 megahertz here is again a large one for the K6-2 500. Now this we'll see as we move into actual game benchmarks as to whether that is consistent. But you can see here it's a fairly linear increase in performance clock for clock. And finally the K6-3 running at 500 megahertz. Now I don't believe there are huge differences between the K6-2 and K6-3 in terms of the actual integer and floating point units. Really the only difference is the K6-3 has on-die level 2 cache, which is obviously amazing and has made a reasonable increase here, even though it is only running at the same 500 megahertz. It does have a nice step up, but not significant. So now let's look at the floating point. Now this is where the benchmarks do change a bit. For some reason in this set, the K5 did really poorly. Now that doesn't come across to a lot of the other benchmarks. I'm not sure if there was like an incompatibility with this program or the way it tests that, but yeah, on this test, the K5 did not do well. Now, we can look at the PR200 versus the Pentium 133, and this is where you can see quite a big difference when compared to the integer performance. Unfortunately, a K6 running at 150 megahertz can't even match a Pentium at 133 megahertz. Now, not a huge difference here. I would actually class them as fairly similar. When you look at the game benchmarks, there's a little bit more difference sometimes. But in this test, they're fairly close. The next set of CPUs is that PR333, the K6-2, and Pentium 233 MMX, all getting fairly similar results. Again, the PR333 is a little disappointing here, seeing as it is the fastest clock for clock out of those three CPUs, and still slower than the K6-2 at 200 megahertz. The K6 at 200 megahertz really, I think, does quite well, considering that it is running at a slower speed to the Pentium 233. So really, in floating point, the Pentium so far and the K6 in this benchmark is looking quite close. Next over we jump to the K6-2 300. Now again, a big step up from the Pentium 233, but not as big as the integer performance. Now we can look at the K6-2 500 and the K6-3 Plus, and these get effectively the exact same results. So this is very interesting. The cache has made no improvements to this benchmark for the floating point, and that again is expected. It is not the floating point units in both are the same. So now we will move on to some memory throughput benchmarks. To be honest, these benchmarks are a bit all over the place. Some of these benchmark results don't really make a huge amount of sense to me. You've got CPUs in the same class getting better results than others. So I don't think there is much value to these. But there are some outliers that you can get from it that do give us some good ideas of maybe how the CPUs are, what they're focusing on. So the one thing you can see from the read performance of the memory here is that the Cyrixes run very well. Now, both the PR200 and PR333 run at a 75 megahertz front side bus, so you would expect those to have better memory read than, say, a Pentium or K6 running on a 66 megahertz front side bus, but they are also beating the K6-2 300, which is interesting. And then the other strange thing is the K6-2 at 500 megahertz has a faster memory read than the K6-2 at 300 megahertz, which I would not really have expected. And so, as I said, this benchmark is a little bit odd, basically. The Pentium 133 has supposedly better performance than the K6 when reading in memory bandwidth, which doesn't translate to any of the other benchmarks I've seen. So maybe there's a problem with the benchmark. Maybe that is the case. I've run these benchmarks a few times and they do seem to come back fairly consistent. So maybe there is more than just memory testing that's going on here. The next one, though, is very strange. This is the write performance. The reason why this is so strange is the PR200 is getting significantly higher write performance than the PR333. Now, both these chips are based on the 686 core, both have a 75 megahertz front side bus. There's really no reason the PR333 should be running at slower memory write performance. Not sure what the reason for the result is there. The other strange one is the K6-2 300 is now got faster write performance than the K6-2 500. So yeah, I can't make much sense out of these benchmarks. I've just included them as of interest. I think in future I will look at some different benchmarks to test memory throughput. So let's jump on to CPU mark. This one definitely relies on cache and memory throughput. That seems to be a big factor. And also I think integer performance really does play a part in this. So you can see here again the K5 and the Pentium 133 are very much the same. K5 is running a little bit faster than the Pentium, so its integer performance clock for clock is better than the Pentium. The Cyrixes do quite well in this benchmark. So the PR200 is out ahead of the PR133 and the Pentium 133. Then you can see when we step up, the PR333 is quite a lot better than the K6 and the Pentium 233 MMX. It's interesting to me is that the Pentium 133 and the Pentium 233 don't see a huge increase in performance here. That I've seen on other computers with Pentium chips, this benchmark they don't score very well in. So look, that does somewhat match up with the memory throughput. The Pentiums didn't have the best memory throughput either. So I do think this one is very much a memory throughput cache as well. Then you've got a nice step up to the K6-2. And this is interesting here, the K6-2 300 and the K6-2 500 really don't have a huge difference. But the K6-3 Plus is massively faster. This is like well out ahead. And this is obviously the benefit of the L2 cache on die. And this is why the K6-3 had such a good reputation for like office performance and spreadsheets and things like that. That on-die cache really made these kind of processors very fast. Anyway, let's move in to the first game benchmark, which is Quake III. I've done a 640x480 to keep the video card not as a bottleneck, but I have also done the benchmark at 1024, and those results are listed on the Vogon's wiki page, which I will list below. So here we can see that the K5 is getting 11.3 frames a second, which is totally respectable for a 100 megahertz CPU, slightly slower than the Pentium 133 at 13 frames a second. So again, these CPUs seem surprisingly close in performance. So I would say that the integer performance of the K5 is better, and the floating point of the two are very similar. Now, the K6 PR200 has done badly here, which is to be expected. Did not have a good reputation, but you can see here that the PR200 at 150 megahertz is still quite a lot slower than the Pentium 133. So, yeah, quite a big drop back there. Then the next three CPUs all have, again, fairly similar results. Unfortunately, again, the PR333 coming in last against the three CPUs in the middle. The K6 is doing very well again. This CPU surprised me throughout all the benchmarks. It's done very well and really keeps up with the Pentium 233. Then jumping to the K6-2s, where we have a massive improvement here. I think there's a few reasons. One, the 100 megahertz front-side bus. Quake III loves memory throughput. And also the 3D Now technology is utilized in this set of benchmarks. So good performance scaling here. The K6-3 got an even bigger jump, considering it's again running at the same frequency as the K6-2 at 500 megahertz. So we're getting up to 48 frames a second from that chip, which I think is pretty good. I think I was benchmarked at Pentium 2, I think it was running about 400 megahertz, and that was getting about 51 frames a second. So while still not Pentium 2 performance, clock for clock, it is a big step up. So for Quake III, the K6-3 does, I think, quite well. Next, we'll move on to 3D Mark 99. Again, the same thing happened with this motherboard as the other one. The K6 PR200 returned a terrible score. So this benchmark obviously has some Pentium instruction that's not running at full speed on this K6 chip, or whatever it is, but it just does not do well here. Again, the K5 and Pentium 133 fairly evenly matched here. Pentium 133 still coming out ahead. But if you had a K5 at 133 megahertz, it would have been very similar. Then jumping up to the next three CPUs, the Cyrix, again, disappointing here. It's only sort of just keeping up with the other two while running at quite a significantly higher clock speed. Again, I'm pretty impressed with the K6 here, remembering it does not have any 3D Now technology, so it is running the same as what the Pentium 233 would be, and they effectively, looking at it clock for clock, are very similar. K6-2 here has a massive jump. I do think that the 3D Now technology helps in this benchmark and the front-side bus. But this is where it gets interesting, is the K6-2 500 is not significantly faster in this test. And I have seen that the clock scaling of the K6-2 really kind of runs out of steam at 500 megahertz. The front side bus is a limitation, the cache is a limitation. It just can't utilize the CPU's performance, which is there. It definitely, if you certain benchmark scale very nicely, but for games and full system benchmarks, often the K6-2 at 500 is only 20% or so faster than the K6-2 300. So I think really the scaling really starts to drop off at probably 350 or 400 megahertz for a lot of these tests. Here again, the K6-3 is obviously quite a bit ahead, considering that it has the same speed in megahertz. So again, the cache really does a big improvement here. And I must admit, in some of these tests, I'm surprised how much the difference it makes. Let's move on to 3D Mark 2000. So unfortunately, this benchmark requires MMX technology, so our first three chips will not have any results. The next three, again, we're getting this very similar score. The PR333 from Cyrix, even though it's running at 60 megahertz faster than the K6, the floating point performance is still worse. So clock for clock, it's really not very good. Pentium 233 comes out ahead again. So really the K6 and Pentium have almost the same floating point performance. This benchmark, again, I think heavily relies on 3D Now, and you're getting a lot better performance out of the K6-2s here. So again, nice scaling here. Again, the difference between the 300 megahertz and the 500 megahertz, the K6-2 is not huge, but still a good result. Next is Unreal Tournament. This one definitely is a little different in terms of what it obviously likes in terms of how the system is set up. It doesn't seem to be as impacted by memory throughput. It does to an extent, but not significantly. So again, the K5 and the Pentium 133 almost matched exactly. So that's a good result to see. The K6 could not run Unreal Tournament. I had the same issues as the other motherboard. So unfortunately, this CPU, it would, if you had it back in the day and you wanted to do gaming, a lot of stuff probably wouldn't work. Then we've got the next three. Now this one's interesting because the PR333 has done better than the K6-2 100 megahertz. And this I've seen in the other benchmarks as well. Unreal Tournament works quite well on the Cyrix CPUs. Still not clock for clock as good as the Pentium, and not clock as good as the K6, but definitely better than before. So I wouldn't be surprised if this has maybe there's some integer performance, integer instructions used more on this than say Quake III. But again, these CPUs perform fairly similar. The next three CPUs, the K6-2s and 3s, while faster, are not significantly faster in this benchmark. So that is interesting. I'm not sure the exact reason why they don't scale as well as some of the other benchmarks. But again, we're seeing that the K6-2 is quite a bit faster. K6-2 500 again is 20 odd% faster, and the K6-3 definitely benefits from the cache. So it is a nice step up there. And finally, a new benchmark that I have added is a conversion of a WAV file to an MP3 at 128-bit encoding. Now, this benchmark for these ones I've shown here use the technology that the CPU can do. So that's MMX and also 3D Now. Now, I have also tested some of these newer CPUs with MMX and 3D Now disabled. Those results are in the Vogon's wiki page, but what it basically shows to me is while the performance is improved by MMX and 3D Now, it is not hugely significant. We're talking 10-20%. So it doesn't change the order of these results. So the PR333 is a little bit lower here than the Pentium 133, so it has not performed quite as well. Probably clock for clock, the Pentium is slightly better here. The Cyrix really, again, is dropping back and is slower than the Pentium 133 by quite a lot, and also slower than the Cyrix PR133. So this one looks like a very floating point heavy benchmark, but it is not significantly reliant on throughput or cache, for example. It literally just uses the floating point unit really hard. So this one's a good floating point unit test, and I'm quite glad I've added it. I do still want to try and find a more balanced integer-based benchmark. I think so far out of all of them that I have in terms of real-world case tests, not the synthetic benchmarks, Unreal Tournament is the best one for a mix, but I do want to find some application-based ones that are more integer performance-based. So maybe, I'm not sure if zipping and compression, stuff like that is something that we could look at, so that might be a test for later. But again, in this one here, the Pentium does quite well. Either this encoding software likes the Pentium instruction set, or just this CPU, this test shows the real floating point performance of these CPUs, and that's possible. So again, the Cyrix PR333 is lagging behind, disappointing. The K6-2 does trail the Pentium 233 here, which is not a surprise, seeing as the Pentium 133 did so well. So the 233 has also got a really good showing here. Now the next one is the K6-2 300. Now this was using 3D Now, but when I disabled 3D 3D now and just use MMX on the K6-2, it was still quite a bit faster than the Pentium 233. So it's definitely a quicker chip. Now this is one of the few real-world benchmarks where the K6-2 500 scaled, very I think it's like a 50% increase in performance versus the K6-2 300. So if you did a lot of encoding back in the day, the 500 megahertz K6-2 would have been quite a big improvement. But if you were doing gaming and things like that, the K6-2 300 would not have been significantly slower, and it would not have been a worthwhile upgrade. Whereas if you're doing this kind of stuff, K6-2 500 is quite nice. Now the other interesting thing here is the K6-3 is not significantly faster. It is definitely measurable, but not significantly faster. So the cache is not so relevant in this set of benchmarks. So that concludes the benchmarks. I think the takeaway I have here is that really the K6 and Pentium 233 have very similar performance, especially in newer titles. The Cyrix benchmarks in anything floating point is terrible. Now, it's still faster than the previous motherboard. This new motherboard has made all the CPUs faster. So I don't believe there are any issues with these results. But yeah, you can easily see the floating point performance does not keep up. The K5 has done pretty well for its clock speed. Probably doesn't quite meet the PR133 rating. So that wouldn't have probably gone down well with people back in the day. But if it was advertised and ran at the same clock speed, it would have been quite competitive to the Pentium. K6-2 is obviously the best, and I think the 300 megahertz is a really good sweet spot. It's provides a good level of performance, and the faster chips just don't scale with the megahertz as well. K6-3 is obviously another step up. It does, in certain circumstances, is a lot quicker. Like Quake III is quite a nice jump up. And for some of these other tests as well, like 3D Mark and Unreal Tournament, it is definitely a step up. Not significant. Doesn't really change. You won't keep up with a Pentium 2 in floating point, but is definitely a good step up if you're looking for the maximum performance out of your system. So there are the results. I hope you guys found it interesting. There's obviously more CPUs that I can benchmark later, but I think this is a good set of results for what we're looking at. Again, the Win chip would have been lovely to add, and potentially that Cyrix PR333 would have been nice to have as well. But this otherwise covers all three manufacturers: K5, K6, K6-2, K6-3, Pentium MX, and the Cyrix chips. So really, it's been an interesting set of results. This, obviously, the worst chip by far is the Cyrix PR200. It really only keeps up in integer performance, clock for clock, with the Pentium, and then there's like half the performance of the actual floating point unit of the Pentiums. So yeah, that chip I would avoid. For like general office tasks, the Cyrix M2 is good, and was a really good match with that previous SAS board that we tested before. So would have no problem suggesting a Cyrix for an office-based machine back in the day. But yeah, if you're gaming, you want to be running a K6, a Pentium MMX, or a K6-2 or better. Anyway, if you have any suggestions for other benchmarks or want to see any other chips, let me know. But that's all for now. Thanks very much.